This is lesson 4 of chapter 3 of probability and statistics. Our topic today is the 68, 95, 99.7 rule. Our central outcome today is that you will be able to estimate the proportion of individuals in a given normal density curve. Okay, so here we have our density curve. And so the 68, 95, 99.7 rule, these are percentages. All right, 68% of the data in a normal distribution lives within one standard deviation of the mean. So 68% of our data is going to be right in here, one standard deviation away. Right in here, one standard deviation away. And so then 95% of our data is going to lie within 2 standard deviations of the mean. So here's where 95% of our data is going to lie, right in those 2 standard deviations. In those 2 standard deviations in here. Okay, that's our 95%. And then 99.7% of the data is going to lie within 3 standard deviations of the mean. So 3 standard deviations of the mean is 99.7% of our data. You can kind of see that visualized up there. And so this is true for every normal density curve. And so with that, we can start to make some predictions and we can start to see some relationships in data. So here I have a set of data. It's normally distributed with a mean of 100 and a standard deviation of 20. So what we're going to do first is we're going to actually make our normal density curve. So our mean is 100. That's going to be right here in the middle, 100. If it has a standard deviation of 20, it means if I go up 1, it should be at 120. If I go up 1 more, it should be at 140, and then third standard deviation should be 160. And then we can go the other way, 80, 60, and 40. So, for the first one, it says percent of scores that are less than 100. Well, here's 100. And it's going to be everything that's less than 100. Well, remember, 100 is the median, it's the mean. It means it's in the middle of the data. So if it's in the middle of the data, it splits the data in half. And so to the left of that, less than that, we're going to have half the data. Well, half the data is 50% of our scores. It's as simple as that. And now we have between 80 and 120. Well, 80 is here and 120 is here. So it's all this data in between these 2 red lines. And remember, that's 1 standard deviation away from the mean. And 1 standard deviation away from the mean in both directions is 68% of the data. So there we have 68%. Alright, now we have to figure out what's less than 140. So I'm going to draw out a line at 140. Here's 140 right there. It's going to be what's less than 140, so all of this space. So my initial reaction is always to say that it's 95% of the data. However, it's not 95% of the data. 95% of the data lies between 140 and lies between 140 and 60. Okay, so it's going to be 95 plus whatever this area down here is. And the way we find that area is actually, if you think about it, underneath this density curve is 100% of the data. And 95% of it is going to lie between this 60 and 140 right here. And so then 5% of the data is going to lie down here in this tail and up here in this tail. But we're not including this tail up here, we're just including this tail. So we take half of 5%, which is 2.5. We add that to that 95%, and we get 97.5% of our data. That can be kind of confusing at times. Just remember that whenever it says that if it's saying that it's less than, and they're not just talking about the mean or the median, you're going to have to do a little bit more work to get some stuff included. So it says between 80 and 100 now. Well, 80 is here and 100 is here. And if you remember, 68% of the data lies between 80 and 120. So we're only using half of that data, so we go 68 divided by 2, and that gives us 34%. Oh, cancel. 34% of our data. 20, so let's go up, let's look at where 120 is. 120 is right here, and it's less than 120. It's all of that space. Well, remember between 80 and 120 is 68, so we know that it's at least 68. But remember, we're still including this part that's not part of that. And together, this whole thing's going to be 100%. Well, 68% is in this middle chunk right here, which means that 32% has to be included in this end tail and this end tail, but we're only using half of that end tail. Half of 32 is 16, so we go 68 plus 16, and that gives us 84%. Our last one says that it's whatever is greater than 120. Well, if 84% is less than 120, if we do 100 minus 84, we'll figure out what's greater than 120, and that gives us 16%. Alright, so here we have the mean weight of adult American men is 180 pounds. So that's our mean, that's in the middle, 180 pounds. With a standard deviation of 25 pounds. The weights are approximately normally distributed. Use the 68%, 95%, 99.7% rule to approximate each of the following. Okay, well, let's make our curve. This is 180. This has got to be 205, 230, and 255. Down here we get 155, 130, and 105. So, it says what percent of all adult American men have a weight less than 130 pounds? Okay, so here's 130. 130 is 2 standard deviations away from the mean. And so if you look at those tail ends, that's going to be 5% of the data. But we only want half of that 5%. That must be 2.5%. What percent of all adult American men have a weight between 130 and 205 pounds? All right, 130 and 205. Let's find where those are. Here's 130. Here's 205. So here's where we have to be a little bit careful. We can figure out this in chunks. So here we have that middle part, that's 68% of our data. Okay, 68%. We're going to have to add stuff. We're going to have to figure out how to add this to it. Well, remember if this middle part right here was 68%, that means all the tails together are 32%. Half of that 32 is 16. So this chunk right here is 16, but we don't want all of that. We just want this 130 to 155 piece. So if we think about these tails, this tail part here, this tail part here, those are 5% of the data. So that means that this is 2.5%. So if we take that 16, we subtract 2.5, we will get this little chunk in here. 16 minus 2.5 gives us 13.5, so we add 13.5, and that's going to give us 81.5%. Here I just copied that density curve onto another slide. The question is what percent of all adult American men have a weight less than 105 pounds? Remember, 105 pounds is 3 standard deviations away from the mean, and so that's that 99.7. So if we think about that, there's going to be, if it's going to be less than that, there's 0.3% that's going to be less than and greater than those standard deviations. We want half of 0.3%. So we take 0.3 divided by 2, and we get 0.15% of our data. Alright, that was the end of lesson 4 of chapter 3, probability and statistics. Write your summary and your questions. The essential outcome for today is that you'll be able to estimate the proportions of individuals.